Welcome to Python Basics with EJD. In this video, we'll be talking about creating your own Python package. All right. In the first video about an introduction to Python packages, I already showed how we can create very simple module. Is how to create a module simply and how to create a package which is made up of two modules that time. So this time around, I want to go into some details about creating your own Python package. For the most part, it may look really tricky, but if this is really what you're interested in pursuing, you may find it very useful. So creating your own Python package, right? So why do you need to create your own Python package, for instance? Maybe if you search, if I believe that whatever field you are in, if you want something related to Python, you can find it. So all you just need to Google is maybe Python package for architecture, Python package for pharmacy. If they don't exist and you think you have the facility to make it happen, then you can then be the first writing a Python package for your specific need, right? Okay, so let's move on with this. The first thing you want to do in creating your own Python package is to pick a layout and structure your package. All right. So it's recommended that you have an SRC layout, which prevents accidental import from your working directory and makes tests realistic. So here you have my awesome package SRC. So this is a level of how the whole thing goes. So you have my awesome package. So whatever you want to call your package, right? Then you have SRC, my awesome package. So you have this to show that it's a collection of more than one module. And you have the core PY, that's a module inside of that, and then you have the utilities, right? You have the init py again, another package. So io.py is contained in that. So you have test underscore core.py, and you have readme.md. So of course, the whole thing, the license, that story we saw when we looked at information about NumPy, that kind of thing. So you also want to do your own manifest.in, that's optional for non-code files. Then you have git ignore, changelog, md, and all of these things. So what do these things do? What each piece does, right? So you have src slash awesome underscore pkg. So that's your importable package now. All right. So based on this tree, right, based on that structure, all right, that's your importable package. So underscore double underscore in double underscore dot py marks a directory as a package. So once you see double underscore in double underscore dot py, that marks a directory as a package. And then you can define double underscore all double underscore version and top level export here. Then for submodules, so you have submodules like utils slash io.py, so all this now like submodules, this utils, all this, they are submodules. All right. So keep code organized by concern. Then you have tests. So these are unit tests. That's PyTest recommended. You have pyproject.toml. That's build system plus metadata using PEP 517, 518, or 621. The manifest.in include extra files in the that's source distribution. Then readme.md is long description on your PyPI. All right. The license is you choose a permissive license like MIT slash Apache 2.0 unless you need otherwise. Then changelog.md is semantic versioning changes. Of course, from time to time, you may need to update your package, and that's why we have different versions for packages and libraries like that. So example minimal package code for src slash my underscore awesome underscore pkg backslash front slash double underscore in double underscore dot py. So this is the minimum thing you can have for that. So you have, of course, this is just a comment now. My awesome package, tiny example package, just say from dot core import grit, and then you have double underscore or double underscore, and you have grit double underscore version double underscore. That's maybe it's version 0.10 like that. So you have that, right? Another one. Of course, these are not to be run because you don't really get any result. Or maybe I can just run for the fun of it. Yeah, we don't expect any result. Maybe it can even give error sometimes because it's not like the full thing. Just a kind of we are just breezing through to show what is possible. Then we have src backslash front slash my awesome package core.py. So we can also, in this case now, we can say define great name, you supply a string. So it means the name you're supplying would be a string, right? And then you can then have so you have something like this. So this one runs perfectly good. So that's the core.py. What about test slash test underscore core.py? So you now have from my awesome package package import greet. Of course, my awesome package didn't work in the first place, right? But I mean, if you want to now import greet, this won't work too, because no module named my awesome package is defined because we don't have this, right? We don't really have this. Except, well, I don't think I want to go that route actually. Should I try? Should I try? Should I try? Okay, we can actually use the Google Colab AI to our advantage. So I can just say I won't try. I try to cut the chase if possible. Build. I can just say build the package, right? Build the package. So if it's wasting time, I'll just move on. Build the package. So that's one advantage of Google Colab. You can, with the assistance of AI, you can actually get some things done or do a kind of debug. Oh, you can see this is a lot. This is a whole lot. So accept and run now. Wow. So it's doing all of these things. Successfully installed. So still going on. Okay. So that's one advantage that this one gives. Cannot access this. No such file as direct or directory. So it's still working. Requirement satisfied. Okay, so I guess okay, still it's still doing some stuff. Okay, let's get oh okay, wow. It's still trying to to do something. Okay, we can stop it already. We can stop it already. We don't have all the time. Yeah, I think this is better. I'll just stop it. So I mean, but you have seen the possibility of what you can do with all these things. How far does this even go? Advanced topics. Okay. Yeah, so I can delete all this now. I'll just delete all this. What happened there? Hope I did not delete something important. Uh, can I undo? Control MZ, Control MZ, Control MZ, Control MZ, Control. Okay, I think I don't need all this. Because we already have 35.5 separately. 35. Yeah. Okay, we are good. So I can delete. No worries. Okay, so I'm good to go. So with Google Colab, you can, if you have the patience, you can go through the whole process. So for me, I'm just running through all this. Okay, so here we were here talking about copyright. So of course you can also, okay, I can remove all this now. I can clear all outputs. Good. Everything is neat again. So we saw this test backslash test underscore call.py. Then 35.2, we can have package metadata. That's like pyproject.toml for the modern way. So you prefer PEP 621 metadata in pyproject.toml. You must choose a build backend. The most common are setup tools, classic, very flexible. You have the Hatchling, that's fast and modern. Poetry, dependency and build management in one tool. I think we saw poetry in the last video. So below are two popular routes. So you can use setup tools with PEP 621, talking about pyproject.toml. So you have all these syntax, build system requires whatever, build backend project, and my awesome package, description, a tiny example package that says hello, all these plenty things. But we did a very simple package in the previous, in I think even in the first video, I think. So notes for version now, manage manually or via a tool like setup tools underscore SCM. Then optional dependencies install via pip install my awesome package dev. Then setup tools or packages are fine with where SRC ensures correct discovery. Then you can use hatch lean, like lean and fast. So you have pyproject.toml with all this whole story. So a tiny example package, a programming language, Python 3 license, and all these things. Then when do I need a setup.py, for instance? So for modern packaging, you don't need a setup.py. So if you have pyproject.toml plus, your build backend replaces setup.py. So only add setup.py if you must support very old workflows. If needed, a minimal setup.py can simply forward to setup tools.setup like that, or prefer pyproject.toml. So the TOML takes care of new realities. And this is optional to setup.cfg, that setup tool style configuration. So if you are on older patterns, you might see setup.cfg for metadata and configure, and the tiny setup.py with PEP621 stick to pyproject.toml. Then we have 35.3 include package data and non-code files. So if your package ships templates or data, ensure they are included. So with setup tools, encode reference files via import lib.resources. I mean, this can be technical for the most part, but that's okay. So from import lib resources, import files, and all that. So add to manifest.in, that's the source distribution, and configure inclusion for wheels if needed. Then with recent setup tools and package underscore data slash include package data, you can simplify. Test by building next section and inspecting the wheel. Then we have build distributions, that's wheel plus source distribution. So you can install build tools once. So you have Python minus dash m pip install upgrade build twine, then build Python dash m build. Then you get this distribution, an awesome package. So you have the 0.10 version, wheel preferred for install, and sdist for source. Then 35.5, you can test it locally with this kind of thing. So from the project root, you can install your build wheel into a clean venv. We saw venv, I think, in the last video. And then you can run tests by doing things like pip install pytest, and then you can do pytest-q. Then for versioning and change log, right? If you need to change versions from time to time, so you can use semantic version in semvar, and then the format is major.minor.patch. So major is breaking changes, minor is new features or backward compatible. Patch is bug fixes and backward compatible, right? So maintain changelog.md with clear sections like added, changed, fixed, deprecated, removed. So yeah, we need to see all of that to know what kind of change you're actually doing on the package. So optional automation of versions from Git tags. So you can have setup tools underscore SCM. So for setup tools, I think if we click this, it takes us to GitHub or something like that. Yeah, so it takes us to GitHub, right? So back here, so hard version commands for hard projects, poetry version for poetry projects. Then there's linting, typing for CI, all recommended. So you can have run for links or formats. You have all these pyproject.tml, tool.roof, line dash length equals 100, target version pi 38. So that's linting and typing, right? So for run, you have rough check and rough formats. So you have mypy for types, mypy src, PyTest for test, and coverage with this. I mean, this looks really tricky. So you have GitHub Actions. You can test on Pi 3.8 to 3.12 matrices built on tags. Then for console scripts, so you can expose entry points so users get a command after install. Then you have setup tools, PEP621 style. So project.script, hello CLI, my awesome package. So in core.py now, you can define the function main, you import sys, name, sys.a, add v1, if length, all the stories. Then publishing to test PyPI and PyPI. So you can create accounts. So you register on PyPI and test PyPI, and then you create a PyPI API token recommended and store it securely, locally via keyring or PyPIRC, or pass to CI as a secret. Then optional, you can have this also. Okay, so you have the whole thing. These utils, index servers, PyPI, blah blah blah, using all of these things. Then you can also upload to TestPyPI first. So if you need more clarity on this, you can actually get this code sheet but just follow the link in the description, so it can take you to the Google Drive where you can download this. All right. So upload to TestPyPI first. So you have this You have Python dash m build, twine check this, that validates long description, and then you have twine upload for repository and test PI distribution. Then you can install from test PyPI. Sometimes dependencies must come from PyPI. And then you also have Python dash m venv dot venv test and all that. So if all is good, you can upload to PyPI. So I'm not implementing all of this. I'm just breezing through. So common publishing pitfalls. So you can do something where the name is already taken, right? That's a common pitfall. So common publishing pitfalls, name already taken. So you can pick a unique project.name, then missing readme stroke long description. You can twine check. Twine check will warn you about this once you have a missing readme or long description. Then non-PAP 440 version, adjust to a valid one, e.g. 0.2.0 RC1. Then forgot SRC mapping, ensure package discovery is correct. Private files and will inspect built artifacts before upload. Then, of course, you can have advanced topics and tips like namespace packages, right? So namespace packages for very large organizations like my_org, the sub package with modern Python native namespace packages, no double underscore in double underscore dot py, which shows packages, right, are supported. So configure discovery carefully. Then you have extras. You have extras like optional feature sets, e.g. my awesome package plots, data files you prefer import lib.resources over package resources, that's pkg underscore resources, binary extensions, consider maturing Rust or setup tools with compiled C/C++ extensions, provide rules for major platforms, reproducible buildings, so you pin building times, DEPS, use isolated builds, default with PEP 517, licensing, so you have MIT/Apache-2 are common, match your organization's policy. Security, sign releases, and use trusted publishing on PyPI, OIDC from GitHub Actions, that is. So quick checklist, right? Quick start checklist. So create repo with src / layouts and pyproject.toml, write minimal package code plus test, build with python-m build, run twine check, upload to test PyPI, install and test from there, upload to PyPI when satisfied, tag and release, bump version, update, changelog. So I mean that's like a lot, but I'm not interested in that direction right now, but just to expose you to this idea right now. So with this, I come to the end of this video. Let me know how helpful this has been for you. If you have not subscribed already, you know you're missing a lot. So you want to go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released, right? You can take it further after subscribing by becoming a member of the channel. Just click on join, and then that gives you some extra privileges, like having a one-on-one chat with me if you are part of the gold group, right? And of course, ultimately, you want to like, share, comment so that more people can have access to the great content I have going on here. So, like, come your way again. Keep doing Python right. Bye.